Welcome, everybody. Hope you're having a good conference and everything. The title that's listed outside says Functional Programming in Kotlin, and that was the original title that Hadi Hariri had proposed. And it turned out that Hadi was unable to make it here, so I'm kind of filling in for him. And I'm going to do functional programming in Java and Groovy and Kotlin. I'll go for all of them. And therefore, I have a bunch of demos in different languages, and I can compare the different languages. And you'll see that there's differences mostly in level of maturity. It's how many features they have that fit into the functional category, depending on the language. Interestingly enough, Groovy has the most in this, which I'll show you. And we'll talk about it. In addition, the other guy, I guess, took the books. I have 3 copies of, I have 3 copies of my book to give away. I don't know how I'll do that, based it on, definitely one I want to go to a woman or underrepresented minority, but the other 2 I could go to anybody. I don't care, you know. Just want to make sure I reserve one that way, definitely. Okay, real quick contact information. I will critique these slides and everything. My name's Ken Kousen. It's Kousen like the relative, it just doesn't look like it. My one-person company is Kousen IT, or as my wife calls it, Kousen It. And I'm afraid that's the sort of sense of humor you're going to have to brace yourself for during this talk. So just letting you know. There's my email, homepage, blog, Twitter handle, and I'll put it this way. I'm an older white male, so of course I have a newsletter. But you're under no obligation to worry about that, and everything's free. I'm certainly not going to charge for it. The book that I'm giving away is this Kotlin Cookbook that just came out in December. So I've got, as I say, I have 3 copies of those to give away. Previously, I'd worked on a book called Modern Java Recipes that has the functional features that I'm going to be talking to you about. Streams, lambdas, method references, parallel streams, all that stuff. I've got some older ones on Gradle and one on Groovy as well. Okay. Oh, and some video courses. If you have an account at the O'Reilly Learning Platform, Safari, just put the videos on in the background, let them play. You don't have to watch them. I think I get paid royalties based on minutes watched. Okay, that got a chuckle anyway. Let's move on. Oh, and for what it's worth, my day job is teaching software development training classes, and I'm a certified by JetBrains for Kotlin instructor, if you like. So, okay, moving on. Oh, I do that for Groovy if that existed, and of course for Java, that doesn't exist either, so moving on. Okay, now if you talk about the theory of functional programming, then they like to talk about Lambda expressions. And when they talk about lambdas in mathematics of functional programming, then they're generally trying to refer to a pure function. A pure function is a function that always returns the same output for the same inputs. And in Java, that would imply that the implementation of the lambda was not dependent on any variables in scope. So when you hear the term lambda, it's supposed to imply that. Now I don't want to be too strong in that statement. They're not strictly restricting it to that, but that's the goal. And generally, if that wasn't the goal, they would use the term closure instead. Now, I'm not on the core team. I don't know what the decision process was for deciding between calling them lambdas or closures. But in general, if you're talking about lambda expressions, the goal is to make these pure functions that are not dependent on the context, whereas if you use the term closure, they are. And in Groovy, there's actually a class called closure. And they are dependent. You can modify variables in context as well as access them. In Kotlin, they call them lambdas, but they're closures. Okay, so they really are able to access everything in scope and modify it as well, which is kind of surprising, but it's following the Groovy system there. In fact, Kotlin lambdas look and feel just like Groovy closures. If you have any background in Groovy, Kotlin lambdas will be very intuitive to you. Java is mushy, as it's not surprising in a language with 25 years of backward compatibility issues. They have it so that you can read local variables, but you cannot modify them. The words they use are final or, quote, effectively final, so that you can see them, but you can't edit them. And that's understandable because it's the same rules that existed for anonymous inner classes, which is partly where they borrowed the syntax from. You know, you have your interfaces that have a single abstract method inside them, and that's what you can assign lambdas to, you can assign method references to, and so on. Now, I have a couple of quick demos I just want to show you just to give you an idea here. Now, the GitHub repository for all this code is in my account. So it's github.com. There's my last name, Kouscn. And the name of this repo is java_groovy_Kotlin. And I have the code loaded in IntelliJ IDEA, but there's nothing IDE specific about it. It all uses a Gradle build, and the repository has Java in it, and Groovy in it, and Kotlin in it. So it's got the works. And you can, in fact, mix and match. You can instantiate a class in one language and use it in a different one, and invoke methods, because in the end, it's all bytecodes under the hood. So they're all very comfortable. If you haven't used Groovy before, Groovy code looks and feels much like Java. It's very intuitive for Java developers to learn. Kotlin looks different, has a different feel to it, but it's still reasonably straightforward. Kotlin borrows a lot of features from both Groovy and especially from Scala. So if you have any background in Scala, that's very easy to pick up. I will say this, the killer app for Kotlin, the reason you really want to learn, or need, I should say, to learn Kotlin is if you write Android apps. Because Android is now, quote, Kotlin first, according to Google. Any new development of the Android API, libraries and things like that will be done in Kotlin before it's ported to Java, if they even bother porting it to Java, because you could still call it from Java if you need to. With Groovy, Groovy's biggest feature is how cleanly it interoperates with Java. So almost every Groovy project I've ever seen of a given size is part of a Java project. It's both a Groovy and a Java project. And that's not surprising. You use Java for infrastructure and, well, I like to say it this way. I use Java for libraries and for tools and for basic infrastructure like Spring or Hibernate, and I use Groovy for pretty much everything else. Kotlin, you can almost get there. The biggest difficulty I have with Kotlin relative to Groovy is that it's just that much newer, that much younger, so that it doesn't have features that I expect to see in Groovy, that I just know are there, and I imagine over the years it will grow there. Now, here I have the code in IntelliJ, and I see that when I resize, let me change my font size here to make sure that's working. I want to bring up my font here, so let's make it 28. How about that? Is that visible in the back? Yeah, okay. So I'll go with that. So as you can see here, and this isn't strictly necessary, you can divide your project into source main Groovy and source main Java and source main Kotlin, and the same thing for the tests. In the Groovy world, that's not even all that common. Usually you mix your Groovy code and your Java code together and let Groovy handle it, because Groovy will delegate to the Java compiler for any cross-compilation issues. So you actually make a lot of cross-compilation issues go away by putting your Java code in the Groovy dependency, because then Groovy will resolve the issues there. Kotlin, it's much more common to keep separate from the Java code, but I haven't had any serious problems with it. It tends to work out just fine that way too. I also, of course, have tests in Groovy and Java. I think my magnification's too high here. I have one Kotlin test as well, but you can use any of the languages to test any of the languages. Okay, you don't have to do them all together. So at any rate, in the Java one, I was mentioning Lambdas here, and just a real quick, interesting one here. This is a prime number checker done from a stream point of view to give you a sense of what's going on here. So in Java 7, this is the idiom that we used to use. We'd have loops and we'd have if statements, and here I'm saying is an integer prime using Java 7. I could say, well, if it's less than 2, I'll throw an illegal argument exception. 2 is true. Here I'll take, what I want to do is I want to divide, this is a really brute force, I want to divide the current number by every number from 2 up to halfway. Up to the square root, basically, up to the square root of the number. So round it up. So this is my upper limit, is square root of the number up plus 1. I go from 2 up to the limit. I try to divide by each I on the number, and if it divides evenly, then I return false, else I return true. Now, we're used to writing code like this, but there's a lot of paths through that code. There'd be a lot of tests required. This, on the other hand, is the functional idiom, if you will, the better way we would do it now. Again, I'll throw my exception or set my limit, but now I can say, let's use an int stream on its range closed method, which goes from 2 to the limit. So that includes the upper limit. And there's a method called none match, and none match as an argument takes a predicate, in this case an int predicate, if you will. An int predicate is a lambda that takes a single argument and returns a Boolean. So in my case, I want to supply my number and do my modulus calculation and see if it's 0 or not. So that one little statement there really is the whole calculation. If it's 2, well, I know it's prime. Otherwise, I'll just go through all the numbers from 2 up to the limit, just dividing them one by one. And you see how much cleaner this is in many cases. And you just have to get used to the streams and the functions and the Lambda expressions and everything when you want to do this. Now, I think I have a test for it. So this is a Spock test. This is using the Spock testing framework from Groovy. And it has a nice fluent interface where I could say, okay, each test will say whatever the number is prime, and I put in my prime numbers here. And in Groovy, that's a list. They have literal syntax for lists. And I'm supplying each element to this x. It will go in the name of the test, and then I'll expect its prime with the regular way and its prime in the Java 7 way. And by the way, I figured I better put in some composite ones too, just so I didn't just return true. And also the illegal argument exception part. But the other part here is this PCG thing. I also re-implemented the algorithm in Groovy too, and I just want to show you this to show you how incredibly similar the syntax is. That looks and feels very much like the Java syntax, except here I'm using a range rather than an int stream, and the method I'm using is find, which means find the first value that satisfies the closure. In this case, it's a closure. So the syntax for closures in Groovy puts everything inside the braces, as opposed to the Java syntax, which can leave them out on an expression lambda and adds them after the arrow on a block lambda. But in Groovy, the whole thing goes in braces, and same thing happens in Kotlin. So in fact, if I was to implement this in Kotlin, it would look almost the same, almost identical. So just to give you a sense of what these things look like, that's why I wanted to bring this up. Most people are familiar with the Java part, and I have a few others, but I figured that's enough. Now, Groovy uses these closures instead, and what becomes interesting is that in Java, they deliberately added a layer of indirection, right? It's like every problem in computer science is solved by adding a layer of indirection, something between me and where I want to go. Rather than having our methods like map or filter reduce on collections, they added this stream metaphor, which was a little unfortunate because we already have I/O streams, so we have to distinguish between I/O streams and functional streams, but so be it. If you want to do map or filter or reduce, you have to go through streams. Now, Groovy took those methods and added them directly to collections. Now, of course, the difference will be is that Java functional streams are lazy. They process each element through the pipeline before going to the next element, rather than doing every operation on the entire collection. But if you put the methods on collections, they're eager. You go through the whole set. So this lambdas or map filter reduce here, let me bring that up. So lambdas here. Sometimes I have to look at it to see. Now that's Java. So here is my Groovy section up at the top, because I think they're alphabetical. Right, so lambdas. So this shows you how you would do regular stuff in Groovy. Now the interesting part here, I'll show you the map filter reduce in a minute. The biggest problem I have with Groovy with map filter reduce is that they didn't use the words map, filter, and reduce. I imagine if they had to do over again, they would have. However, this is one of the interesting features of Groovy. If you want to use Java streams, just write Java. So in other words, this is a regular list in Groovy. This is the stream function, the method that's added to the collection interface in Java. So at the result of this, I have a stream, and therefore I can do map, filter, and for each here. And what the argument is, in Java, the argument would be a functional interface. a predicate, or in this case, a function. This would take a predicate. This takes a consumer. In Groovy, you would supply a closure to do the same thing, and it works. Now, Groovy 3, the 3.0 release of Groovy, came out last Monday. I mean, that recent. And what they've done, the biggest change in Groovy 3, is that now you can use Java Lambda syntax even in Groovy. I have not updated this to do that. I left it as it was because it's more idiomatic this way. But now one of the goals of Groovy has always been to be able to take regular Java code, rename the file extension .groovy, and it probably compile. And that fell apart when they added streams and lambdas and method references in Java 8. Now that's back. So this is still invoking Java methods in a Groovy idiom here. In fact, I even am using things like map to int. Now this is the syntax to do a method reference in Groovy. Nowadays, of course, I could, and in fact, let's take a chance, right? What could go wrong? Yeah, see, I can use the method reference syntax from Java now. I did update the Gradle build file to use Groovy 3. So in principle, I can use all those latest features now as well. And there's the normal things like map to int and filter. And if you've done any of this stream mechanisms in Java, that's all very familiar code. Okay, the map filter reduce one, again, the problem is that they use the wrong words. So in Groovy, they use collect when they mean map, which is really unfortunate because Java uses collect. But Groovy didn't know Java was going to use collect when they came up with it. So that's the downside. They use find all for filter, and then they have built-in reduction methods like sum, just like Java has as well. So here I did double all the values, find the ones divisible by 3 and add them up. Or here I've got a collection of cities, and I map them to uppercase versions and sort them. The false means make a new collection, so I'm not modifying the existing one. And then I could join them all with comma and wind up with comma-separated values like that. Or again, there's a collect, and it's sort by a property here. In Java, the stream method would be sorted, and you'd provide a function that took the current value and extracted a property from it that was implemented comparable, and then it would sort by that key. So before Java 8 had that stuff, this was really great. Now that Java 8 has the stream capabilities, the advantages are not as dramatic, even though there are still some there. Okay, so let's go on. Now, Kotlin does things a little differently. They use the fun keyword for your functions rather than methods. I promise that of all the bad gags I'm planning, I'm not going to do any related to that. Okay, you can write your own jokes there. But the thing that Kotlin has, one of the features that I really like in Kotlin that isn't in the others, is that if your implementation of the body of your method is a single statement, it could go over multiple lines, but if it's a single statement, you can actually assign the signature to the implementation directly. Now, this is a little unusual. You know how you write code and then 6 months later you look at it and go, I don't think I'd do it that way anymore. This is legal and perfectly fine, but it's much more common to do this if the right-hand side returns a value. And print line returns void, so sometimes people don't use the single expressions for print lines. But this is still legal to do so. In fact, here's more of an example. This would be the full form of a sum function in Kotlin. Notice that the variable types are declared after the variable name. And if you want a return type on a method, or function I should say, that goes at the end of the signature. But because this is all a single expression, you can reduce it down to this, and that's what it looks like. Kotlin also allows you to do what they call top-level functions. You can have a function in a file by itself that does not appear to be in a class at all. And they call those top-level functions, and much of the standard library is written that way. It's actually very interesting to browse the standard library when you're working with it and see how they implemented things. And they really like those top-level functions. Think of those as static methods in Java or Groovy, okay? Because there is no static keyword in Kotlin. So they have to have another way to go about that. And one of the ways they do it is by doing top-level, as they say, functions that are in a class without a name. Now, functions in a file without a class. Now, if you want to invoke those from Kotlin, you just use the name, and the namespace is the package, just like package is used for namespace with classes. However, if you want to call a top-level function in Kotlin from Java, you use the name of the generated class. So for example, if there's a file in the standard library called console.kt. It's got the print line function in it, in fact. In fact, I can actually show you here that if I look at a Kotlin example down near the bottom, again, alphabetically, does this have, oh no, that's not one. That's for a demo coming up. How about this guy? And all I want is a print line, and it must be in the test, I guess. Oh, I did? I don't see a print line. Am I missing it? Here, yeah, this is the one I'll go to. So at any rate, let me go inside here, and you can see this is in a file called kotlin.kt. If I wanted, and of course I'm on the JVM, so look what it does. It just turns around and calls system.out.println, you know, exactly what you'd expect on the JVM. And if I want to invoke that method from Java, then I need to know that by default, the generated class name is the name of this file with a KT at the end. It would be console KT dot println, because again, it would be a static method in that class, okay? Now that's not a functional feature, it's just an interesting characteristic of Kotlin in general. Okay, so I'll come back to this stuff here. Now, the other thing that Kotlin provides, which is a great space saver compared to Java, is default arguments for functions. So that this one says, I have a read function that reads from an array of bytes, and I can either supply an offset and a length, or if I don't, there are default values for them. And therefore, I don't have to write all those overloads that we have in Java. So that's a great savings. So the idea of default parameters and named arguments, invoking things with named arguments, is something that pretty much every modern language has, just Java doesn't. And that really cuts down on the verbosity of a lot of these things. Really helps a lot. Now, looking at more functional features again, I want to demonstrate this lazy streams idea, and I have it here in Java. All right, that's getting old. Let's do this. There we go. So lazy streams. Okay, so what I have here is a, let me go to my test associated with it. So what I want to do is I want to find the first even number that's divisible by 3 after doubling them. And what you'll see here is I have this. I have a function that's going to multiply by 2, and it would just be n times 2. And normally I just write that. I wouldn't have to write a whole method here. But I want to print out that I'm inside it. Likewise, I have a function here that does modulo 3. I said div, but it's really mod 3. And again, I put it here so I could print out that I'm inside it. So here, this function says the first even number divisible by 3 here. I'm using Java to say, let's make an int range from 100 to 200. Just pick numbers. That's 100 to 199. I will double them all. I will filter them by divisible by 3, and then find the first, which of course in Java returns an optional. So I'll do an or else. Say if I didn't find anything, I'll return a 0, which doesn't fit in this range, so I'll know something went wrong. It's like an error code, okay? Now, if you don't know Java streams, this looks incredibly wasteful because it looks like I'm doubling 100 numbers and I'm filtering 100 numbers, and then I only wanted the first one. It's like a ton of wasted effort. But if instead of putting the lambdas directly in here, I call those functions, then what you'll see in the verbose one, when I invoke that, is that, let me execute that, is that it actually processes through the entire pipeline, element by element here. Oops, that's the first one. And then here's the other one. Let's see. See, I'm inside multiply by 2 with 100, then inside divide by 3 with 200, and that was rejected. So then we go to the next one for 101 and double it, and then that's not divisible by 3 either. So then we go to 102 and double it, and that is divisible by 3. We're done. See, we only went through 6 calculations because the stream was lazy. Okay? In Groovy, by adding the methods directly to collections, they're not lazy. So if you have a short-circuiting condition, you don't want to do that. Now, of course, in Groovy, if you have a short-circuiting condition, just use Java streams. There's no problem there. Now, in Kotlin, they don't do it that way. In Kotlin, they did add the methods directly to collections. So those are not short-circuiting, if you will. Those go through the whole process. But if you do want the same stream-like lazy behavior in Kotlin, they have sequences. And all you do is convert to a sequence. So for example, down here in my Kotlin one, I have this lazy sequence here. So again, if I just look at this, here's my numbers from 100 up to 2 million. But if I say as sequence, then I could do my map, and here I just put the print inside the lambda, just to make it easier. There's the doubling. Here's the filter, again, putting the print inside, and then invoke the first function. And if I just ran this as a main method, again, you will see I'm only doing the handful of calculations the same way the Java one did as well. So if you're used to stream behavior and you're working with Kotlin, go to sequences. Okay? But if you understand Java streams, you know pretty much everything there is to know about sequences. The only other interesting thing about sequences is something that Python people might find interesting. They have what's called a sequence generator. So that this is part of a top-level function called sequence. It takes as an argument this suspend function that maps from nothing to unit. I mean, there's all this stuff in here. But the point is, this says invoke the block over and over again and just keep getting values out of it until I tell you to stop, that sort of thing. So this is an infinite sequence, if you will. And therefore, this says start off with a pair, and now I'm going to yield the first one to the output, and then I'll make the new terms by taking the second to the first and the second to the first plus second. And if you think about that, you'll recognize what that actually is a Fibonacci number generator. Because each time the value becomes the key is the current value, and then the argument is the value is the next one in the sequence. Which leads to one gag. Did you hear that this year's Fibonacci conference is going to be as good as the last two combined, right? Yeah, I'm sorry. But the thing is, this looks infinite, so what actually happens when you do it in practice is that, I thought I had it here, but I think I had it in a test. At any rate, is you call the take method. You invoke take to say how many elements you want, and that's a very common method in functional programming. Take and drop. There's usually methods like take while and drop while. Java now has those on streams once you get to like Java 10. So Java 11, the current long-term support version, has both take while and drop while on streams. They have a lot more short-circuiting methods. So this idea of having an infinite generation, well, Java streams are the same way. You can use the generate method to create a stream that is infinite, and then with Java, you normally put a limit on it. Here you do a take or a drop, that sort of thing. So same idea. Now, Kotlin has map and filter and reduce, except the weird part is that in Java, the reduce method takes either one argument or two. If it takes one argument, it's a binary operator. How do I produce the next value? Okay, and use this for an accumulator. Like, oh, here's my sum, and I'll add the current to, and that's my new sum, and then I just go around. But if you use the two-argument version, then the first argument is the, quote, identity value for your binary operator. So on sum, it would be 0, or on multiply, it would be a 1. And you use that to initialize the looping variable. So if there's any chance there would be no values at all in the stream, then you use the two-argument one. Well, that all sounds good, but what Kotlin did is they said, you know what, let's make reduce the one without the extra argument, and fold will be the one with the extra argument. So instead of overloading it, as they did in Java, in Kotlin, they made two separate methods. Now, I assume there's a functional reason for that, but I don't really care. I just need to know that there are two. And you could do a fold left and a fold right, and Groovy also has all of those as well. Except that Groovy, again, because they got there too early, got the wrong names for everything, their method is called inject, of all things, instead of reduce or fold. Scala calls it fold. Kotlin borrows a lot from Scala, so that's usually where they get that. But the closures come from Groovy, you know. Okay, so I'm going to move on. Now, one of the neat things you can do in Groovy is that you can make a Pojo instead of a Pojo, a plain old Groovy object instead of a plain old Java object. And this allows you to just write like 4 or 5 lines of code, and you get public getters and setters, you get named constructors, you get sequence constructors, sequential arguments, named value arguments. You get a toString method, an equals method, a hashcode method. Now, if you're a Java person, then you can do the similar sort of thing with Lombok. Use that and have it auto-generate all that stuff. In Groovy, that happens automatically. That's all in there. And in Kotlin, they use what's called a data class. I'm a little disappointed they didn't call them Pocos, plain old Kotlin objects. I hear in Python you could refer to them as popos, which sounds vaguely disgusting, And if you want to upset a Ruby developer, now Ruby developers are easygoing, but if you want to upset a Ruby on Rails developer, which is not hard, okay, but start referring to poros, because for some reason Ruby on Rails people still are annoyed that Java exists. You're like, why is anybody still using Java? They don't get it. I'm like, okay. Whereas the Ruby people are really laid back. So I refer to poros just to annoy them. So, Actually, I don't. I'm telling you to do it. I don't like getting in trouble. I like causing trouble. It's different. Okay. Now, to give you a quick little example, in Groovy, whoops, hit the wrong button here. I've got this golfer system here. Okay, so you see, this is a golfer in Groovy. We have a first name, a last name, and a score. And I can add this annotation @sortable, which lists which order to sort them in. So if I actually want to sort my golfers here, then here is 5 golfers. So there's Nicholas, Jack Nicklaus, Tiger Woods, Tom Watson, Ty Webb, and Bubba Watson. And all I can do now, first of all, here is the Java approach to sorting is I make a stream, and then I invoke the sorted method to do the natural sort, and then I could print them. Or I could do, let's just go down to here, sorted with a comparator, comparing int of the score, and then comparing by last name, then comparing by first name, printing them out. We've been able to do this since the stream functions came out in Java. However, where's my Groovy one? Click on that, and then here is the sorting demo. Oh, that's Java. Just a second. So here is the Groovy sorting. Okay. So again, same golfers. I do have to ask you. I mean, everybody knows who Jack Nicklaus and Tiger Woods, and hopefully you know Tom Watson and Bubba Watson. Anybody recognize Ty Webb? Caddyshack. Thank you. So what'd you shoot today, Ty? Oh, I don't keep score, Judge. Well, how do you compare yourself with other golfers? By height. Yeah, at any rate. So there's my collection of golfers, if you will, in a list. And then all I have to do is invoke toSorted, and now they're sorted. That's done. See, now that's, again, on the collection itself. And I could verify that they work, and I could print each out, or I could get the last one. Or the false here, again, would be to say make a new collection rather than modify the existing one, and it also takes as an optional argument a lambda that would say what property are we sorting by, for example. Now this does show one other thing that comes up in both Groovy and Kotlin, but not in Java. In Groovy and Kotlin, if the last argument to a method is a lambda or a closure, then you put it out after the parentheses. So in fact, this is a 2-argument sort method. The first argument's a Boolean, the second argument is a closure. So it is considered idiomatic in both Groovy and Kotlin to put the lambda after the close parens, which is interesting. It looks funny at first, but you get used to it, and it means you don't always go hunting around for a close paren. You can see those right there. But I have to know that when I look at the docs here, that is in fact a 2-argument, well, okay, that's a little different. But at any rate, it would be a 2-argument method that I'm looking for, because the second argument, the last argument, is the closure. Okay? All right, now, Kotlin data classes do something very similar to what Groovy Pogos do. You put the word data in front of the word class, and by the way, there's no braces at the end of this. That's the whole declaration of the customer class. And by putting in val here on both of these, those become attributes, and if this resembles a constructor, that's what it's supposed to do. You're basically defining the primary constructor and defining the attributes as along the way. And by putting the word data on this, then you get generate getters and setters. Now I used val, so that means in Java, that means final, so I won't have any setters. but I'll get getter methods for the properties. It'll automatically generate a toString, an equals method, a hash code, using the same prescription that Josh Block laid down all those years ago in the Effective Java book, same one your IDE generates. You also get this nice little copy method. For those of you who go back a ways, like I do, then you may recognize a copy constructor. It'll say, take an existing one, and I'll invoke copy and just change the properties I want to change. And it'll start with that original. And it also has these component end methods, component 1, component 2, component 3, so I could assign an instance of customer to parentheses first and last, and it will fill in the values top down from attributes in the class, interestingly enough. So Kotlin took the idea from Groovy, or Lombok, if you will, and added some extra stuff, the copy function as well as those component methods. Now, destructuring, as they call it, with a data class happens, but what really happens a lot is on maps. Because when you destructure on a map, you assign a map, say, for each parentheses key, comma, value, and it automatically separates the key and the value for you. So that's just a nice feature of Kotlin data classes. What they essentially did is they took map.entry and made it a data class so that you could destructure it that way. Okay, now let's start looking at some more interesting things. I have a little geocoder here, for example. Let's see if I have it handy. Now, I'm giving away my key for the geocoder, so be kind. Okay. What this is Google maintains a RESTful web service that only supports GET requests, so that's why I'm not too worried about this. And what it does is you supply an address, and it will generate JSON data or XML data, depending on what you ask for, that includes the latitude and longitude inside it. So what I have here is the base URL, and they do their content negotiation right in the URL. So it either ends in JSON or XML. The REST advocates wouldn't like that. Do you know what they call themselves, those REST advocates? You heard this? They're called Restafarians. Isn't that awful? I didn't come up with that. That's not me. Okay, but just letting you know. So they don't like content negotiation in the URL. They'd rather use an accept header inside the request. And of course, then they would object to my whole statement and say, if you go back to the thesis, you know, the one from Roy Fielding back in 2000, it doesn't restrict you to HTTP at all. And why are we talking about requests and URLs? And yeah, okay, let's move on. Okay. So at any rate, what this does here in Groovy is I need to assemble, I have a location. Now this is my Pojo, if you will. So I have, actually, just to show I could do it, this is a Java Pojo. So this is massively verbose, right? We have, I've got 84 lines to wrap 3 strings, you know? Okay, so I've got a street, a city, and latitude and longitude, right. I've got my constructor to set them. I've got getters and setters, toString, equals, hash code, you know, the works. But that's a Java class, and yet I'm supplying it to a Groovy method, fill in lat long, which extracts the street, city, state, and then URL encodes them all. Well, URL encoder, that's from Java again. So we go back to Java for the URL encoder, join the result with a semicolon, that's my URL encoded address. That's the complete address. The entire query string is address equals that encoded, and then my key up here. And then Groovy has something that Kotlin doesn't have, which is a JSON slurper, believe it or not. That's what they call it. But that's built into the library, which will take JSON and allow me to parse the details. Now, in this case, I'm using a parse method that takes a URL. So I create the string. We have the string interpolation, which Kotlin also has. I convert it to a URL because Groovy adds a toURL method to string. So does Kotlin. They do an extension function to add toURL to string. This parse method goes to that destination, downloads the JSON data and parses it, and hands me the root. So I could just walk the tree, the first result, get the geometry, get the location, and from there I could extract the lat and long. Of course, it's JSON data. They come back as strings, basically. I convert them to big decimals, and if I go look at, I think I have a test for this guy, then I can put in, you know, there's Moscone once, and here's the pirate museum, because I have a pirate example coming up later, right? I mean, I don't have any ninja examples, but I do have a pirate example, so coming up there. And you'll see that what this does is that it actually computes the lat and long here, and then I just use, I'm using the Hamcrest matchers to make sure I'm close enough to the right result. So you can use Groovy to make it easier to build the URL and access the RESTful web service, but I can integrate it with Java Pojos if I want to. So it's really an illustration of use Java for what Java does well and use Groovy for what it does well, for example. Okay, now, going beyond. Now, if you've used Java for a while, you're familiar with a lot of the things I just talked to you about. Groovy adds a lot more. So let me bring up these annotated functions, for example. So let me close all this and bring up annotated functions. Okay. One thing that Groovy adds is an annotation called memoized. What memoized does is it automatically builds a cache of values so that the keys in the cache are the arguments to the method. Here, a big integer. And the values are the result of the function. So this is great with pure functions, and here's my Fibonacci generator. So normally, you would never write a recursive function like this because you get a combinatorial explosion in the number of calls. But if all you do in Groovy is add the memoized AST transformation, as they say, it'll automatically generate the cache, and all the intermediate values will be saved in the cache. So the first time it computes fib of 5, it does it, but the second time it's already in the cache. So that, in fact, I can execute this for numbers in the thousands or tens of thousands without having any memory issues. And I didn't have to convert this to an iterative process. The annotation builds the cache right off of it. Now, this only works for pure functions, as you might imagine. Here's the same thing with a factorial calculation, memoized factorial. Just n times fact of n minus 1. It just keeps track as we go along. Basically converts the whole recursive method into an iterative one, if you will. They also have tail recursive. Now, to use tail recursive, you have to write your function so the last call is a call to the same method with different arguments. Okay? So sometimes you have to do this, and this is where default arguments come in really handy. I want factorial to be the number and the value of the accumulator, but when I call it, I don't want to provide an accumulator value. I just want to call it with factorial of 5 or 10 or something like that. But if I add a default argument, I can call it without that, and G here indicates big decimal. So then it says if n's less than 2, well, return the accumulator. Else, call factorial of n minus 1 and n times, there's the accumulator, multiply by n to get in there. And again, I can do this and scale enormously. Now, Kotlin has a keyword called tailrec. So you write a function that looks very much like this, and you put the keyword tailrec on it, and again, they will reuse the stack frames. Everything will be fine. If you write tail recursive methods in Java, they look tail recursive, but you don't get the memory savings. You'll still overflow like you did before. But with the tailrec keyword in Java or the tail recursive annotation in Groovy, now you get that behavior. Works out very nicely. Let's see, that's that one. I had another one in mind, composition, for example. Okay, this is not as helpful as I thought. So the Groovy here, and here's my composition one. Now, this is something Java does not have. What this is putting methods together that are lambdas. You're saying apply this lambda, then apply that lambda. Now, in the functional interfaces, like consumer and predicate and function, they do have methods. Like in consumer, they have an and then method or a compose method, but they're specific to that type. In Groovy, I can use the right shift operator to compose any two closures together to say, take the result of the first one and make it the input to the second one. And that way, it feels more like the Unix operating system, where you got a whole bunch of little functions and you pipe them all together, which is the goal of functional programming. You have something that's small and simple and easy to test, and then you compose your bigger programs out of that. So Java sort of has that, but again, very limited. Whereas Groovy has this in spades, and Kotlin doesn't have it at all yet. But I imagine it will eventually. You know, that's what I mean by having a new language. The other thing that shows up in Groovy, again, probably because it's mature, is a method called Curie that has, unfortunately, nothing to do with Steph. Sorry about that. The idea behind the Curie method is you take a lambda and you replace one of the arguments with a value, and that produces a new lambda. Now you can actually replace one of the arguments with another lambda. I don't want to get into that. But here, for example, I have an add closure. Take two values and add them up. And notice, by the way, in Kotlin, I'd have to give these data types. In Groovy, the implication here is any class X that has a plus method that takes a Y, whatever it is, will work on this. So I could use, for example, in Groovy, I could use the date class with an integer, and it'll just add days to a date, that sort of thing. And I could write the closure very abstractly that way. Well, I can invoke it with a call method, or I could just use it with parentheses and add that up. But you can say, let's make the first argument a 3 and made a new closure called add3. So X is now 3, and now I just supply the Y, and I've generated a new one. And they have an R closure to curry from an R curry rather to curry from the right side rather than the left side, and so on. So again, this is stuff that Groovy has, but Kotlin does not, and Java didn't even consider. Okay, that's not even part of the game there. Okay, now, metaprogramming. So I've got to do my pirate example real quick, and then I have a couple others to go through. So what I've done here is, I hope you appreciate this, I have paid money to subscribe to a RESTful web service that allows me to turn strings into pirate speak. It cost me $5 this month, so okay, you know, I mean, this is important. So my pirate one is under metaprogramming. So here's the idea. Now, what I'm doing is not just writing the method, I'm actually adding it to the string class. So I'm adding a pirate method to the string class. That's what this meta class is doing. Add a pirate method, reads my key. Okay, that key I did. It's in the GitHub repo, though. I'm sure I'll get a complaint sometime. This is the URL, the base URL. Again, the text I want to supply a URL in code and then provide the key. And then when I build up the URL, I convert it to a URL, and then that'll invoke the getText method to download what is JSON data. I use my JSON slurper to parse it, and then this is walking the tree. So here are my examples. I'm going to do hello world, how are you today? Please fill out your session evals. And of course, I'd like to add you to my professional network on LinkedIn. And these are the results I get out of there. There's ahoy world, that's not bad. How be ye today? Please fill out your session evals. I'd like to add you to my professional network on LinkedIn. Or, you know, I don't know. So weak, but I needed a demo. So there you go. But that sort of metaprogramming is doable in Groovy. Now in Kotlin, you could do something somewhat similar. In Kotlin, I have my same website, different translator. I'm doing a Yoda translator. And in this case, what I did is here's the JSON response that comes back. I commented it out. So you get a total big object here, and then success has a total, and contents has translation and text, and then the translated value. So I built Kotlin data classes to map each of those. Now, by the way, you don't generally need to map them all if all you're doing is a GET request. If you're going to do post, put, or delete, then you have to get everything that isn't null. But here I'm just doing the basic stuff. So there's my translation, and I'll read my key out of there, and I put in my query string, and I decided just for grins, I'm using Java 11's HTTP builder class. So just to mix, again, Java back into my Kotlin, this overly verbose stuff is so that I could do Java in my Kotlin. And basically down here, I get back the JSON, I parse it using Google's JSON. Notice, by the way, Kotlin doesn't use the new keyword. If you want to instantiate an object, you just use the constructor without the word new. So that's what this is doing, converting the body into my Yoda response. And I'm actually getting all these things from a file called strings here. So here are my strings I'm going to translate. You know, I had to try these for Yoda. And let's see if this one works. I mean, that's weak. I would have expected a better Yoda translator. You know, I mean, complete your session evals, please. Yeah, all right. I guess I can live with that. That's a Henny Youngman one, I suppose. You know, oh boy, is that dated. If you want to throw an OK boomer at me, I have no defense. I don't. If you're going to do it though, I think you should accompany it with a really good eye roll. I mean, it just seems to go together. Okay, nobody's laughing. Moving on. Okay, so at any rate, you can do metaprogramming in Kotlin too. What I've done is I've taken the string class and added a Yoda method to it. So that down here, when I invoke these things, I'm invoking the Yoda method on each string. And I'm using the useLines method, which produces a sequence of all the lines and then closes the file automatically. So nice, comfortable mechanism there. Okay, couple last quick ones. I did that one. And okay, now unfortunately, I promised people cat pictures, and this has worked every time, and then this afternoon it decided to stop working. So I'm going to blame internet access, even though so far it seems fine. You know, but if it doesn't work, let's blame internet access. You okay with? No, anyway. Here's the thing, though. This is the sort of thing that Groovy makes really easy to do, and Kotlin would take a bit more work, and Java wouldn't do it all. So this is my 2 cat ones. It's under a Flickr package, I think. Yeah, okay. So I have cat pictures and parallel kitties so that we could actually do parallel streams and everything. So the idea here, and notice one of the things you could do in Groovy and Kotlin is you could alias imports so that when I access window constants, I could just call them WC. So here I read my key from Flickr, and then here's the endpoint. It's a REST endpoint at Flickr. This is a Groovy map, key, value, etc. I'm using the Flickr photos search. If you think the Rastafarians didn't like the word JSON in the content negotiation, imagine how they must love having the actual method inside the URL. But at any rate, there's the function I'm calling. I want JSON back. I'm going to search for the word cats, and I want 6 of them, 6 photos. So what I do is this whole mess here takes that params map and joins them into strings, key equals value, and then joins them with an ampersand. So this whole little thing right here is to build my query string, and then take the URL, convert it to a URL, get the text. So that retrieves the JSON data. Now, to show you that everything is working, I'm going to append the data to a file and pretty print it. So you actually will see the JSON data. And then I'll extract the photos out of it. And then this is something that is unique to Groovy of the 3 languages. They have what they call these builder classes. And this swing builder will let me create a JFrame with a title and set visible to true and pack and set default close operation and all this stuff. And I'm going to walk through each photo. This is the actual URL of the photo from the JSON response. I'll print it so you'll see it there. And then I make a JLabel with an image icon that has the URL in it and the tooltip text. And unfortunately, like I say, this worked for years. And now when I run it, what's going on is it does get the data, and there's all the links. But for some reason, I'm getting blank. It's the image icons are not rendering. And I know they're there because I checked the data. The data's all there. So sorry. But what I can do, just to prove they're there, is I can click on one of these, and you see, you know, oh, that's not oh, there's a cat. See, that's the danger of this demo. I don't know what we're going to get back, you know? So it's a real risk here, you know? But okay, worth a try at any rate. So at any rate, all the images are there. And then to make it a little bit more interesting, I also have this one, the Parallel Kitties demo. So it's basically the same stuff, except this time I'm going to use a Java parallel stream to try to download all the images simultaneously, or using the thread pool. And I map them for each photo. I'll print out the thread name so you can see what thread's operating. There's the URL. I convert it to a URL and download the bytes, and then collect them into a list, and then the rest of this is just rendering again. And once again, I just won't see the images rendering for some reason, but see the threads going on there. What I did do in here is I threw in a label with just to show you the cats are in there at all, you know. But that's too bad that the cats are not showing up. But all right, so be it. Okay, and then I think the last demo I have, they say you can tell a developer if you whisper the word time zones in their ear and you can just see a shudder go down their spine, you know. These are the time zones in Antarctica. The funny part doesn't even leap out at you right away. The funny part is the South Pole here. See, it's in that hashed region. That's called the Ross dependency, and it follows the time zone rules for New Zealand, which means the South Pole, 6 months of darkness and 6 months of daylight, some part of the year is on daylight savings time, believe it or not. So what I've done is I'll show you since I already did a Groovy example, let me show you the Kotlin example of this. So in Kotlin, I have my Antarctica script here. I'll do it in script form. So what I'm doing is I'm getting all the available zone IDs. So this is using java.time to get the zone IDs. That comes back as a set of strings. So I get a set, and I'm going to filter it, and you see there's my lambda. So I'm using this regular expression to look for the word Antarctica inside the string, filter by that. I map them. This converts them into a zone date time. So because I need a zone date time, because zone date time has the get offset method with get total seconds. In other words, I want to sort them by time zone. And that's the easy way to do it. Go drill down to the offset from GMT and sort them that way. And then for each here, I'll print them. I'll print out the offset, the zone, and then this mess is the is daylight savings time mechanism. And I even have that separately. So when I execute this, I'm trying to make it full screen here. Oh, the heck with it, I'll just drag it up. There, you see, there's my time zones. Somebody is trolling us on that, although I think that's actually Greenwich Mean Time, believe it or not. But still, and there's all the time zones in Antarctica, and yes, sure enough, the South Pole is currently on daylight savings time. So that's Kotlin mixed with Java to do that. And you could do all of these. So to summarize, Groovy and Java is an inevitable pairing. Like I say, I've never seen a Groovy system of any size at all that didn't have Java in it, because you use Groovy for the parts that parse XML, or the things Groovy does really well and Java does horribly, like parsing XML or generating XML. You use Kotlin for, well, anything you use Java for, but it also has some functional features that go a little beyond what Java has. Groovy goes way beyond. I imagine eventually Kotlin will have those features too. So easy to mix the languages together, and again, I have everything in a GitHub repository, and I had no trouble at all mixing the languages and no cross-compilation issues to speak of. It all worked just fine. So we want to give away those books. Where are the books back there? So I need to... All right, I'm going to keep it simple. We have a nice lady right up front here who's been quiet. So I always want to make sure I give something to one of the quiet people too, because they tend to, they don't want to raise their hand on anything like that. But now, I'll tell you what, why don't I delegate this to you? We'll just pick two people out there. Not him, not Dan. He's ignoring me anyway. He's on the phone. So, Dan, you're supposed to not be on your phone during these things. What? Oh, yeah. Okay. All right. Well, at any rate, I'll hang out for a couple minutes because we actually run into break time now, so it's really well timed. But I'll hang out if you have any questions, comments, or anything. Otherwise, thank you very much for coming.